Welcome to our part 2 on sampling distributions. In this video, we're going to look at determining the mean and standard error of a sampling distribution. So in our last video, we looked at creating a sampling distribution for the sample means, and then we looked at what the mean and the standard deviation of that sample mean distribution was. So in our video, we had 4 laptops as our population. However, what happens if we have a much larger population and then take a larger sample size, such as a sample of 100 at a time? So I have a program here to kind of simulate that. So we're going to have a population of 75,000 random numbers between 1 and 500, and they could be decimal numbers. And now this time we're going to look at a sample size of 100 instead of only a sample size of 2. So let's see what happens to our mean and standard deviations of not only our population, but the samples as well. So if we go ahead and run this. So looking at 75,000 values between 1 and 500, the mean of the population is 250.41, and then taking 8,000 samples, each of which has a sample size of 100, the mean of those sample means is 250.73. So notice the mean of our sample means is very close to the mean of our population. And then if we take a look at our standard deviation of the population is about 144.05. The standard deviation of our sample means is about 100, or not 100, is a 14, about 14 and a quarter. So roughly about 1/10 of the value as the population standard deviation is. So notice the mean targets our population mean. So again, by targeting, we mean that the mean of our sample means here is very close to what the actual population mean is. And if we take a look at that means that our population mean is going to be approximately what the mean of our sample means is. So this notation here, this mu with a subscript of an x with a bar over it, is the mean of the sample means. And that, again, is going to target what our population mean is. Also, the standard deviation is around 1/10 of the population standard deviation. So this 14 and a quarter is about 1/10 of 144.05. And for that, we take our standard deviation of our sample means. So that's this sigma here, standard deviation of our sample means. And if we divide it by the square root of our sample size, it's going to target what the population standard deviation is. In this case, we took sample sizes of 100. So if we take the square root of 100 is 10. And again, we can see that the standard deviation of the sample means is about 1/10 of the standard deviation of the population. And again, if you're worried about the so here's one that's even closer than the last one was. 14.359 is roughly 1/10 of 143.74. Notice the means, though, are very, very close. This time they're only off by about 0.06, or not 0.06, 0.05. So this value here, the population standard deviation divided by the square root of n divided by the square root of the sample size, is called the standard error of the mean. And that's something we're also going to take a look at in our next section, which is on confidence intervals. So we'll see this in the next section as well. It's called the standard error of the mean. All right, so example 4, IQ scores are normally distributed with a mean of 100 and a standard deviation of about 16. A sample of 200 participants had their IQs measured. By the way, IQ scores just tell you how good you are at taking IQ tests. So don't put too much faith in them, and, it's not worth it. So here is our 200 participants' IQs. Notice it's not as spread out as our population was. And again, that's because when we look at standard deviation of, we have to divide it by the square root of the sample size. So not going to get as much spread around the average with the sample. So more on that in the next video. But here's a histogram of the IQ scores that we measured from this group. what are the approximate mean and standard error of the sample? So the mean of the sample is going to target the population mean of 100. So again, our population mean is 100. Our approximate mean of our sample is going to target that value of 100. Our standard error is going to be population standard deviation of 16 divided by the square root of our sample size, which in this case our sample size is 200. So 16 divided by the square root of 200 is about 1.13 as our standard deviation. So 1.13 as a standard deviation, our data values on average are going to be about 1 and maybe about 1/7 or so units away from the mean, which again we can see if this is our mean of our sample, then going outwards we're not really going out that far, so we're only going by about 1.13 each time. So again, standard error is about 1.13. All right, that about does it for this video. Thanks for watching. I'll see you next time.